we're going to do two more and look at some more interesting answers here. So same strategy, solve both at the same time. So 5x minus 19 less than or equal to 1. Then we got an OR statement, so it has to satisfy at least one, but not necessarily both. And then we got minus 4x plus 3 less than negative 6. So solving this one, isolating the x term, we can add 19 on each side. So you get that 5x is less than or equal to 20. And then dividing each side by 5, you get x is less than or equal to 4. So that's one solution. Over here, you have this minus 4x term that we need to isolate. So we can cancel out the plus 3 by using subtraction on each side. So minus 3. So you get minus 4x less than minus 6 minus 3 would give us negative 9. Now dividing by negative 4, since it's an inequality and you're dividing by a negative, you have to flip the sign here. So this just becomes 1x, and now it's bigger than 9/4 because the two negatives are going to cancel. So these are our two solution sets, and 9/4, by the way, is just 2.25. So that's what 9/4 is equal to. So x has to be bigger than 2.25, and it has to be less than or equal to 4. So we'll use this information. We'll draw our number line now, and I'll put 0 as our reference. We're going to put 9/4, which is that 2.25, and I'll also put 4. So it's not perfectly to scale, but it's pretty close. And for this one, x has to be bigger than 9/4, but not including it. So we'll use an open circle, and it's every value bigger than that. And for this yellow one, x has to be less than or equal to 4, and it can include 4, so I'll do a closed circle here, and then everything less than that. So this one's an interesting one, because notice when I do my regions, I have one region there, one region in the middle here, and then one region on the end. And it's an OR statement, so that means it has to satisfy just one of them. It can satisfy both, but it just has to be at least one of them. So values over here, like 0, minus 10, minus a million, whatever we want to use, they all satisfy this one, less than or equal to 4. So all values in region 1 satisfy at least one of them, this inequality here, and so therefore they are part of the solution. Likewise, region 2, which actually includes both of these regions, so a value like 3 in here. So 3 is bigger than 9/4, so it satisfies this one, and it's less than 4. So this region 2 actually satisfies both of them, which is fine. That would be part of our solution set because it just needs to satisfy at least one of them. So it can still satisfy both when it's an OR statement. Now this region 3 out here, it satisfies this white inequality, so a value like 10. That would be bigger than 9/4. Even though it's not less than 4, it does still satisfy this one, and it only has to satisfy one, so region 3 would also be a part of the solution set. So what's interesting about this problem is that literally any number you pick on the real number line would satisfy one of these. And so therefore, all values of x are solutions. So this is every number on the number line works in at least one of these. Now, if this was an AND statement, it would have to be this region in the middle where both of them are satisfied. But since it's an OR statement, only one of them has to be satisfied, and every number on the number line can satisfy at least one of these. So let's do one final question. This will, again, be kind of a strange one with an interesting answer. So let me just make a little more room. So we have 12x plus 7 less than minus 11, and we've got our AND statement. And our second one is 5x minus 8, bigger than or equal to 40. So we'll solve each of these. So minus 7 here, you get 12x less than minus 18, divide by 12. To get x by itself, you get x is less than minus 3/2, just like the one we did above. And over here, we have to add 8 on each side. And so you get 5x less than or equal to 48. I'm sorry, bigger than or equal to 48. And then dividing by 5 here, you get x is bigger than or equal to 48/5, which, again, we looked at above. This is just 9.6. But notice from the problem above that we had an OR statement, and we're looking at the exact same inequality, but now we have an and statement. So yes, it was our first inequality we did. We had an or statement, but now we're looking at the exact same numbers, but with an and statement. You'll see that the answer is quite different. So we've solved both of these. Our next step is now to put it on the number line. So let me draw that out. And again, we'll put 0 as a reference. This is just minus 1.5 if you put it as a decimal. So I'll just write that in. We'll just say minus 3/2 there. And then 9.6 for this one, or we'll do 48/5. So somewhere over there, but that's this inequality here. This x is bigger than or equal to 9.6. And I'll do this one in yellow. And actually, let me change the color on this one. I'm going to graph this one in blue, just so we can color code it. And this is an and statement, which means that to be a part of the solution set, it has to satisfy both inequalities at the same time. So it can't just satisfy one, it has to do both. So x is bigger than or equal to 48/5. So we're going to use a closed circle, and it's all values bigger than that. So a value like 10 or 20 or 5,000 all satisfy this one, but not this one. And we'll graph this one next. So x is less than minus 3/2, and it's an open circle, so all values less than that. And now we want to consider our and statement. So we know that for an and statement, it means that it has to satisfy both inequalities to be a part of the solution. So a value, well, let's first put in our regions. We'll call this 1. This region 2 is where there are no solutions, and then region 3 here, where it's just the blue one. So to be a part of the solution, like let's say minus 5, this number would not be a part of our solution set because it satisfies this one, but not the second one. And for an and statement, it has to work in both to be a part of the solution. So all values in region 1, they will satisfy the yellow one, but they will not satisfy the blue one. So region 1 is not part of our solution. Now region 2 is a little bit more obvious. There's no inequalities here. So a value like 1 does not satisfy either of these. It's not less than minus 3/2. It's not bigger than or equal to 9.6. So all values in region 2 do not solve either inequality. And then all values in region 3, notice a number like 10, it would satisfy the blue one, but not the yellow one. And that's true of everything in this third region. It satisfies this one, but not this one. So this one's an interesting one because there are actually no solutions, because not one number on this number line can actually satisfy both inequalities at the same time. You can certainly have some numbers satisfy one of them, but there are no numbers that satisfy both of them. So when we go into our answer here, we would say D. There are no solutions.